Okay, I think we're gonna get going here. So, TJ Lambert is in here as well, so he will be participating in the chat as well. But I'll be stopping halfway through and maybe even a quarter way through to talk through chat questions as needed. So please put any questions there, and then we'll have contact information obviously here and at the end. So, okay, so the topic today is Helix and design build applications. And we'll go through an overview, kind of how we work, our code approvals, some target applications and case studies, how we support projects, particularly in design build applications, and then environmental impacts as well. So for those of you, I think most people on here are kind of familiar with Helix, but we started in 1999 at the University of Michigan. 2003, we were taken to market by Luke Pinkerton, our president. In 2013, we got our first code approval evaluation report under UES ER 279, one that's still in work today. And that was the first introduction to meeting building code approvals under ACI 318 and 360. In 2017, we adopted Six Sigma principles and became ISO certified. That allowed us to kind of be on a heavy growth plan, as well as a continuous improvement process through quality and in manufacturing. And then in 2020, we gained ICC approval through the ESR 3949 report, and most recently the ER 3949 report as well. So for those who, again, those who don't know what the product is, that's what the product looks like. It is twisted around its axis, and it does include an electroplated zinc coating. This is the 525 product. It's about a very large majority of what we sell into every application. So if you are working on site, you can use the same product for footings, walls, and slabs, among other applications, instead of having various products or various sizes of rebar for each application. The main process of this product is to be twisted around its axis, so our dosages are less than other discontinuous products, comparing us to similar screw versus a nail, because our product has to untwist versus it being ripped out of the concrete, similar to other hooked-ended products or rebar. And this is a small snapshot of what we've seen mainly over the last 10 years. We have over 400 million square feet installed, and more importantly, to what we're trying to do in the market, over 35,000 vertical structures among a snapshot of these companies. And quite frankly, a lot of these companies were in design build applications. Obviously, we provide the one product out of Michigan in the United States, but we have a full structural and engineering staff on hand to support wherever your product is, or a product and project is rather. And we feel that we can support everything from the residential house to the largest companies in the world. So, is there any questions so far? Put them in the chat and I can answer them as needed. So we started back in, like I said, the early 2000s under Department of Defense testing. The original idea was to prevent spalling under blast resistance. So the original control versus the Army Corps of Engineers was 2 layers of rebar with against 10 pounds of C4. We took originally that top layer or that bottom layer of rebar out and put it in with 50 pounds of Helix, and this is the result of that. And what you're going to see here is obviously the panel cracks even with Helix, but the goal is to keep that panel tightly together, which is exactly the same goal as we have today in commercial or residential applications. Concrete gets two things: it's hard and it cracks. But our goal is to, even under the heaviest conditions or the most abusive conditions, to keep that crack from opening up and causing issue overall. So, as we said, the Helix Steel has 2 third-party evaluation reports under IAPMO and ICC. ICC is the group that publishes the IRC, International Residential Code. The IAPMO report allows us to design mainly under commercial applications under ACI 318 for footings and walls, and it allows us to provide a ground-up design for slabs under ACI 360 under yield line approach. our main applications, again, structure, not only structural slabs and paving and flat work applications, but wall footings, pad footings, basement walls, duct banks, piping casements, machine foundations, mat slabs, and what have you. So we can not only take over the flat work applications, but your vertical applications as well on site. Again, your ICC report mainly for residential walls and footings, but we have seen a growing increase in footings that really can be designed either lightly with rebar or as plain concrete. You see that a lot in the Midwest here under frost applications. Very deep footings that maybe don't have a ton of rebar in them would kind of fall into that ICC report. And then once you get through our design approach, we do have the ability to provide a full submittal package for each application, and we can stamp in all 50 states for any project. We do have the ability to stamp in most of the provinces in Canada as well. And then we got a question here of how many twists on average per micro rebar. So each piece of micro rebar is 1 inch long, and you typically see three 360-degree twists or six 180-degree twists per piece of helix. So this is a snapshot of what our evaluations report look like. The first two on your left in the middle are our ICC report, and then the right is our UES 279 report. As you see in the middle, our ICC report does include a supplemental report that has drawings and detailing of exactly what rebar needs to remain across cold joints, doweling, lintel applications, and whatnot. That detailing rebar is very, very important. We have detailed that out for code approval or code officials, as well as engineers and architects. So we have a very diagnostic approach to design build projects. We understand that these projects are specialized. Each one is not prescriptive in nature. So we're going to have a lot of questions both on our constructability side and our engineering side of what these look like. We're going to ask, what are the expectations of these projects? Are there high racking loads? Is there heavily abused areas like a recycling center? The project you see there is actually an agricultural project for JBS in Nebraska. What are the owner expectations? Are they expecting floor flatness ratio or fuller flatness expectations? Are they expecting heavily to durability over 20 or 30 years? Do they have heavy environmental requirements? We're seeing a big increase, especially in the electrification of for energy and for automotive. Are there heavy requirements to minimize the carbon footprint of a particular product? Are there construction constraints? What are the labor and time constraints of the project? Are there other material shortages such as cement requirements, and we have to thin the slab to make sure that the project can be poured in a specified amount of time? Are there insulation, vapor barrier pipe installations within the slab that we have to work around? And then what applications are you looking for Helix? Are you looking for just slabs? Are we looking to monopore footings with the slab? Are you looking for walls and footings to be poured together? And then what are the expectations for quality control? Are you using a blower, for example? Are you using ready mix supplies for quality control? And what are the requirements under dosing? Can you preload, postload, etc.? So we're going to have a lot of questions so that we can prescribe exactly what the Helix expectations and requirements are, and if Helix is a good idea for this project. We analyze a lot of projects, but not every single one is a fit for Helix. A lot of them are, but some of them aren't. And we're going to try and tell you what the best expectations at least we have for you so that you can find the best solution. We're going to walk through a few case studies and kind of analyze how our prescriptive process goes into these projects and how that changed throughout the scope of the project. So the first one is the initial battery plant that we did for General Motors. We are completing the second battery plant in Spring Hill, and we are actually starting the third battery plant in Lansing, Michigan for GM pretty quickly here, as well as a number of other projects for that owner. Barton Mallow is the contractor on this project. The majority of the slab was, an 8-inch slab with 9 pounds of Helix, pretty standard designs. However, there were extreme footing designs under the coder area specifically, where it went to a 12-inch slab down to an 18-inch footing and back up, almost looking like church pews. So we took that to a 12-inch flat slab design so that we not only eliminated the need to excavate that area, but also eliminated the amount of concrete in that area while still holding the load for those coder bridges. What that did was not only increase or improve the constructability, improve the time constraints of the project, but also include or reduce the amount of concrete on site, and overall save the contractor and the owner quite a bit of money. But it's setting those expectations of, what is the engineer willing to allow, what can Helix take ownership of, and what the contractor requirements and are to feel comfortable with that project. Overall, we have the ability to design under most conditions, and in this case, we not only increase the durability but reduce the amount of steel on site by almost 860,000 pounds. But we're happy to meet a variety of applications under expectation. This is a little bit of a different project, but a similar process. So we diagnosed exactly what this owner wanted. This is an axle supplier in the automotive Rust Belt of Ohio, and they were having major issues of joint degradation on site. So what we did was came in heavy slab again with heavy loads, but we went to a 100-foot joint design. And as you can see there, there's not only joint requirements, but there's in-floor heating, there's insulation that we had to work around. So, a lot of different applications. We visited this site multiple times to make sure everything looked good and was set up properly. But the owner is very happy with this project, and hopefully has a great slab for years to come. This is a project. It's a 650,000 square foot tilt building, pretty standard, quite frankly, in the southeast part of the United States. But what we allowed this developer to do was to get in this building 3 months faster. The ultimate leasee for this project is Walmart, actually Sam's Club, for this under the Walmart brand. But what they were allowed to do is they not only direct discharge the footings underneath by reducing all of the steel on site, but also pump the slab over it so you didn't have to dowel in and have cold joints across that. One actually other design that we did was on the north side of this building, where you can see here there's heavy wind loads. So there was additional rebar that went in on that wall footing. And what we actually did was we thickened that footing to get all of the rebar out there because of the increased bending moment requirements. But even by thickening that footing by an inch or two, we were able to reduce or eliminate rather the entire amount of rebar on site. So they only procured dowels at that point. So, it's kind of counterintuitive to reduce or to increase the thicken or the footing. But for this instance, the increase in Helix and concrete made sense because you would eliminate an entire trade on site. It's all communication with the owner and what the expectations are, but it made sense in this application. So kind of thinking outside the box allowed us to completely eliminate a trade. This is an apartment complex near Grand Rapids, actually probably 3 miles from our factory. And again, owner expectations is what we're looking for. So this is Thompson Thrift is the owner. They're actually they're the developer and the general contractor. And we eliminated all of the rebar in this 50-foot footing through our ICC report, but we kept in corner bars because the environmental factors right now in the Midwest over the summer, decreased humidity, increased wind speed, increased heat. It put shrinkage cracks historically of what we've seen in corner bars across footings and walls. So what, the owner expectations to see, no shrinkage cracks to increase the rebar on site was needed, even if it wasn't a structural requirement. So, and then this is a project kind of how high we can go as far as walls are concerned. So these are 24-foot high walls. This is a local manufacturing facility. They actually make the plastic that goes in ICF blocks for Logix and other brands. And what we're able to do is remove all of the horizontal rebar and decrease the vertical rebar so that they could get in this plant faster. We also monopored the slab with the walls and cut them near the thickened edge to reduce or to eliminate cracking. but that monopore system, along with reducing the rebar, allowed it to get in about a week or two faster, and made the owner quite happy. Even if it was a small facility, we were able to kind of eliminate that full trade again and get that contractor off site faster. Again, this project, on the extreme end of what we can do. It's on the near Vancouver Island, off the coast of British Columbia. This site was actually hit by pretty heavy waves in the later part of last year, and the durability aspect, even in those extreme conditions, held up over time. We were able to monopore footings and walls together with an ICF system. I think the Hobbs ICF system was used on this site. Reduced the helix on the first floor. It eliminated rebar on the second and third floor, eliminating the footings and slab as well. So what is the owner expectation? Durability? Is it decreased construction costs? Is it finishability? Is it floor flatness? To make, identify exactly what we need to do on site. So, any other questions? I got you on the a little bit of break here. Okay. Talked a lot about walls, footings, and slabs, but we see a lot of constructability improvements now in things like paving, duct banks, and insulated tilt panels. We've seen an increase with insulated panels, especially with the long lead times of metal buildings and precast panels. So if you have an insulated panel where you're having mesh on one side particularly, that may be a great application for Helix. Duct banks, again, constructability concerns where you're tying rebar, putting in the ducts for the electrical lines, and then putting in a rebar cage over it. What does that look like if you have no rebar on it? You can lay the electrical lines under the ducts, pour Helix in over the top, and you're done. So you eliminate one step of that and go to 2 versus 3 steps. You explain the waves. I believe you're meaning at the ridge at Kettle Creek, but yeah, there was tsunami waves off the coast of British Columbia, is our understanding. I believe it was a tsunami off Alaska, and it came in through it came towards British Columbia. But there were significant waves that came in and shut this island area down for quite a few months. But there was no structural damage in the Helix affected buildings or Helix built buildings. We see a lot of these. Constructability and durability increases through in the Caribbean, specifically with hitting hurricanes and whatnot. So, the longevity and durability improvement of Helix does increase the lifespan of these buildings. We do have, in certain applications, we've done quite a few storm shelters and have FEMA approval under certain designs as well. So, okay, and then not only obviously what the owner expectations are, but what are the concerns and requirements of the contractors on site? Is there concerns with mixing? Is there concerns with pumping? Is there concerns with finishing? We will have a pre-pour call with every project to make sure that we walk through those best practices and making sure that we can minimize the amount of issues on site. We have options. Other discontinuous products only post-load products. We can preload, we can post-load, we can site batch. We have blower options to implement and reduce any concerns that a contractor or a ready-mix supplier would have for this. Finishing, normal finishing practices apply. So, we're require, some sort of vibration, but typical finishing processes, screeds, laser screeds and, floating still apply. We still would like to see, best practices. We do have a couple tweaks here and there. If you're cutting, for example, use ideally the purple blade from Husqvarna or something similar to that for the ultra hard requirements, so that you have clean saw cuts. Pumping, you can pump this product. We have had people call in with concerns. We recommend a 3-inch hose. We've pumped it not only on foundations, but also up to 20 stories for slab on metal decks and walls. We just finished up a project here in Detroit for the Hudson site that was 19 stories of slab on metal deck. So we feel very confident with our product with pumping. We do recommend a 3-inch hose because of the 1/3 aggregate rule. It's an inch long, so we recommend the 3 times that size in hose. And then we have seen a lot of polishing and stamping for that matter, mainly in corridors of industrial buildings. Our expectation is that we recommend a wet polish. We like the fact that you would wait 7 to 10 days, but you are going to see the helix. So again, owner expectation is vital. The helix is not going to stick up, but it is going to be on site, or is going to be seen, because you're taking all the paste off. So that's a very close up view, but you are going to see that it does give it a more industrial finish. It does sparkle over time, but you are again, is the owner going to be happy with that design? So, and then finally, there's the EPD and life cycle analysis. We can provide full requirements for environmental factors. We've seen a drastic increase in this, and with certain inputs from the ready mix supplier as well as the contractors, we can potentially work through mixed designs. We can take out steel. We can reduce transportation costs to meet the requirements of these projects. We do have full LEED certificate or points as well. I believe depending on where you are, it's 6 to 7 points. But I would encourage you to have those conversations, because they do seem to sneak up from time to time with owners that are more and more involved in those processes at this point. So. And I know this is a short webinar. That's really all I have until we have questions here. And I'm happy to answer them unless Peter or TJ have additional questions right now that I missed. So, looks like, Greg, did I answer your questions regarding the waves? I wanted to make sure of that. Foundation walls, yeah, we see a lot of use in foundation walls, both commercially and residentially. We probably put, I would say probably 400 to 500 foundation walls for basement walls in this year. And we have seen a significant increase in commercial walls as well, mainly on the pre-engineered metal building side under stem walls. So we basement walls, because it's braced on the top, we typically see 100% replacement. Commercial walls, we typically will see just extended dowels out of the footing, probably running through the top of the wall, designing more like a retaining wall. So. And then Dennis, 40-foot tilt walls. I don't know what you're referencing as far as insulated or non-insulated. We'd have to look at not only the seismic application, but the thickness of that. I would say insulated 40-foot tilt walls. I think these are typically 32 to 40, and we could look at that in your area. Standard tilt, we do have requirements or restrictions on seismic zones, but yeah, I believe we've done insulated 40-foot panels, Dennis. Hanny, the diameter of the hose for shotcrete, I believe I've seen down to 2 inches. I believe it require a potential plasticizer of some sort to make sure it goes through the hose, but we could work with you on that. I believe it's 2 inches though. And then worried about corrosion on extended slabs opposed to the elements. So I believe suspended slab, you'd probably refer to, if it's a slab on metal deck composite, we're not worried about corrosion because number one, the helix, there's a few things. The helix is buried within the concrete, so it shouldn't be on the surface with best finishing practices. It does have an electroplated zinc coating on it, and it is discontinuous in nature. So if one piece were to rust, it couldn't jump to the next piece. But we do have that electroplated zinc coating on that product to drastically reduce the corrosion. I'm trying to get a picture back to there. There we go. So you see that shininess on the product. It really does reduce that, and we've seen that in significantly corrosive environments. This is a project, for example, on a jetty repair by the Army Corps of Engineers that's exposed to the ocean every day. So, and then what info do you need to reduce dosage for So Joe, what I'd recommend is probably sending either your contact from Helix or submitting it through our submit a button on our website, which I can actually put up here. You can click that button there and submit a project through the website to review your plans, and then we'd assign both a sales engineer and a project manager to that project to make sure that you get what you need for those. So, TJ, can you see the offers or that submit a project button now? Or Joe, can you? Should be up. Okay, perfect. So, as you can use that submit a project button, for anything you need. We're happy to kind of jump in and work with you, your contractor, and your engineer. If there are groups that don't feel comfortable or don't know about Helix, please get us involved. We're happy to do on or either individual lunch and learns for these groups to help them become more comfortable. We do also provide professional development credits, as we're going to provide a credit for this this webinar as well. But what we would like to do is get in front of these people sooner rather than later, so that we can kind of bear some of the brunt to pull Helix into this project if that's what you want to do. So, okay. Haney, what's the size of the course aggregate where Helix is most efficient? We've seen a Helix work in larger aggregates, smaller aggregates, as well as blended aggregates. We've seen significant increases for groups that have optimized the size of aggregates, so we don't have an aggregate size where Helix is more efficient than the other. So. Okay, so special care for stamped concrete. What I would recommend is, we've seen success with either roller processes or stamped mats. I'd recommend that you go through your normal process, make sure it has enough paste on it and Helix is down, and then kind of stamp it after that. But we've seen success in both. Mainly in agricultural applications, actually, with beef processing plants as well as chicken processing plants, so that the animals it provides traction for the animals. But it doesn't require any special care on the surface. Just we'd recommend doing a test area so that it's just it really fits the owner's need and your need as well. So. Okay, so recently had a high-tech tilt project where we lost a panel for lifting, insert, and fell to the slab, cracked, but we were able to relift the panel and patch it and repair it. Well, we appreciate that feedback, Trevor. Trevor has seen a number of insulated panels as well as slabs and paving with Helix, and we appreciate that feedback. So it sounds like, Trevor, at least from what I can tell here, that the Helix at least held the crack together once it did crack and was able to be repaired, as opposed to completely lost. So, which is great to hear. So, if you guys do have projects with Helix and things don't go perfectly, please get us involved. We're happy to discuss options to improve that project going forward through the remainder of the project, or provide additional analyses sometimes to carry loads. We're happy to get involved through the remainder or the entirety of the project, even years later. We're not just a material supplier where we're going to send a product and not hear from us again. Okay. Yes, Dennis, I like it. So our UES evaluation report does require some sort of normal weight concrete. I'm not sure what foamed concrete means, but we have used a number of or Helix in a number of lightweight projects, mainly for slabs on metal deck. So I believe this Altium Cells projects had lightweight concrete on the roof decks there. Just looking here. I believe that's the only one on this application, but we have used lightweight concrete in a number of slab on metal decks in commercial applications. So, okay, I think I'll stay on for a few more minutes in case there's other questions, but looks like we're winding down here. But I appreciate everybody's attendance. And again, if there's any other questions or project questions, please contact us. We're happy to get involved as needed. So, hey, I think I'm going to shut this down, guys. So, okay, thanks again.